Army ant syndrome of behavioural and reproductive traits has allowed army ants to become the premier social hunters of the tropics. Knowledge about the army ants is extensive when it comes to their collective foraging, nomadism and highly modified queens, who are wingless throughout their lives. However, when it comes to the origin and diversification of army ants throughout evolution, very little knowledge has been acquired. The fundamental gap in our knowledge is whether the army ant syndrome of behavioural and reproductive traits is the result of a set of evolutionary events, or if they evolved convergently in multiple lineages. Army ants constitute three well-defined taxonomic subfamilies, two restricted to the Old World and one restricted to the New World. The most supported hypothesis states that the army ant syndrome originated several times in independent lineages, restricted to the New World and Old World respectively. This polyphyly hypothesis is based on the assumption that army ants originated after the breakup of Gondwana and would have independently evolved on separate continents. If this hypothesis were proven true, it would imply that there are multiple origins of army ant behaviour and reproductive adaptations with similarities due to convergence. The validity of this polyphyly hypothesis was tested by using a combination of genetic, morphological and fossil data. Members of the subfamily Serapacinae have long been implicated as the closest relatives to these army ants. The lineages of army ants were tested to see if they evolved from multiple Serapacinae ancestors by generating phylogenetic data from 5 independent data sources, including 3 nuclear genes, a mitochondrial gene, and morphology. In order to test the New World and Old World army ants diverged after the breakup of Gondwana, as the polyphyly hypothesis states, fossil information was incorporated from 9 ant taxa together with molecular phylogenetic data. Phylogenetic analysis of the combined molecular and morphological data reveals strong results proving army ant monophyly. A single origin of army ants implies they inherited their behavioural and reproductive adaptations from a unique common ancestor, and that these traits only evolved once in this group. The majority of contemporary army ant species is located in the African and American tropics, which suggests a Gondwanan origin. New World and Old World army ant taxa form strong sister groups, reinforcing the hypothesis that the breakup of Gondwana into Africa and South America caused this dichotomy. Using Bayesian dating analysis, the dates were tested to see if they were consistent with the breakup of Gondwana. This analysis shows that the estimated age for the most recent common ancestor for the New and Old World army ant lineages was 105 million years ago, a date that is congruent with the timing of the separation of Africa and South America, which occurred 100 million years ago. Both phylogenetic and divergence dating analysis provide results that conflict with the polyphyly hypothesis, and instead support a single origin of army ants. This analysis concludes that army ant lineages must have risen after the breakup of Gondwana. This is also supported by recent fossil discoveries that implicate an early Cretaceous origin of ants. Also, the distribution of the army ants supports a Gondwanan origin. The queens are flightless throughout their lives and only form new colonies from splitting from a mature colony and travelling on the ground to a new location. This way of colony foundation makes long-distance dispersal across ocean barriers unlikely, a conclusion supported by the absence of army ants on islands.